surrounded by you. Your is in a land. Against folks who just 5 minutes using science is written of times brain waves to state of productivity. Transit through the brain, the other one is compared to average people, brain fat actually increases and sustains your performance of letting you stay in zone. It's called all the moments you use brain for relaxation, meditation, sleep, to take it's a procedure of yourself. It's even opinion.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem non-overlapping intervals, and this is actually a problem from the blind 75 list of questions that we've been working on. And we've actually been tracking that list of questions on this spreadsheet. You can see that I do have a video solution on the left side over here for pretty much every single problem in this list, except for a couple that we haven't gotten to yet. So today we will be doing the last interval problem in this list. You can see I solved the other interval related problems already. There's about like 70 people viewing it right now, so I hope that you guys are finding it helpful. And you can see conveniently I made a YouTube playlist for all of the blind 75 solutions. Link to that will be in the description as well if you do want to take a look. So now let's continue with the video. So this problem is definitely like most interval problems in that if you've solved other interval problems before, this one shouldn't be too difficult, but if you're new to interval problems, this one is kind of challenging. So we're given an array of intervals where each interval has a start value and an end value, and we want to return the minimum number of intervals that we have to remove from the list to make sure that the rest of the intervals are non-overlapping. So first question you should ask is, what exactly is a overlapping interval? Well, assuming an interval looks something like this, right? It has some start value, maybe the start value is 1 and the end value is 2, right? Maybe we have another interval that starts at 3 and goes all the way to 4. So definitely these two intervals are not overlapping. But what if we had the interval starting over here? Maybe the end point is 3, but the starting point is maybe 1.5, right? Obviously, in this case, these two intervals are overlapping, right? You can see, right over here, this is the region that they're overlapping at. But the edge case comes when we have a interval, let's say, like this one, that's going maybe starting from 2 and going all the way to 3. Are these intervals overlapping? Technically, this fourth interval, 1, 3, so it starts at 1 and goes all the way until 3. So now you can see that they are overlapping with the introduction of this interval. And things become really simple when you draw a picture, which is why I always recommend drawing a picture for complicated problems. So now we want to eliminate intervals. We want to eliminate the minimum number. It's obvious that we can just remove a single interval, this one that we just inserted, to make the rest non-overlapping. But of course, that's not the only way we could do it. We could instead remove this interval and remove this interval. So instead, we'd remove two intervals. That's clearly not the solution, but there are multiple ways to do it, which is why writing the algorithm for this problem can be kind of tricky. One definitely possible way to do this problem is brute force it, right? Go through every single combination, right? For every single interval, we can choose to remove this interval or to keep this interval. And if we have two choices for every single interval inside the list of intervals, then, the time complexity to check every single possibility is going to be 2 times 2 times 2, basically 2 to the power of n, where n is the size of the input. So that's obviously not very efficient, but can we do better? And we definitely can, and it takes a greedy approach to solve this problem. When we're actually given this list of intervals, the ordering of them could be pretty random, right? But what you can see when we actually draw the picture, why would we want to go through these intervals in a random order? Why would we want to look at this one, then look at this one, then this one, yeah, right? Like in just a completely random order. When you look at it this way, it kind of makes sense to want to go left to right, right? To see, okay, here are they overlapping, here are they overlapping, etc., etc. And the easiest way to do that is to iterate through them in some kind of sorted order. You can probably do it sorted by the starting point or sorted by the ending point. I'm just going to stick with sorted by the starting point, just because it's a little bit simpler for me, but I know that it works in both ways, for this problem at least. So when we iterate through these in sorted order, first we're going to compare these two intervals, right? We want to compare adjacent pairs of intervals, right? And let's actually ignore this example for just a second. Suppose we had just two intervals, right? One interval like this and one interval like this. Okay, they're in sorted order, right? And we're comparing adjacent pairs. So we're going to look at this one and look at this one. How do we know if they are overlapping? Well, if they're sorted by the starting point, we know that either they both have the exact same starting point, or the second one has a starting point that's after the first one's starting point, and that's the case here. But again, how do we know if they're overlapping or not? Well, the easiest way to check is they're not overlapping if this one starts after this one ends, right? If the second one starts after the first one ends, then they're definitely not overlapping. But on the other hand, if the second one starts before the first one ends, then they're definitely overlapping, right? You can see that this is the point that they're overlapping at. Okay, so does that cover all of the cases? Well, there's one more case. Technically, that's slightly different. What if, the first one is really long and the second one starts here, right? So it does come after this one, but it ends before the first one ends. This is a slightly different edge case. Again, they are overlapping. We can detect that with the same condition. This one starts before this one ends. So yes, they're overlapping. But now, suppose we had a third interval that comes next. Remember, we are traversing these in sorted order. So first we're going to compare this one is first, this one is second. So then we're going to compare these two together. Next, are we going to be looking at this one and this one? In this case, yes, because remember, if these two are overlapping, we don't have to remove both of them. We only have to remove one of them. So the choice is, are we going to remove this one or are we going to remove this one? Well, which one do you easiest with this one? Then it becomes pretty obvious. We would want to remove this bottom interval rather than this top interval. And it depends on which one of these I use. That's previously in the output of intervals removed like this, and we want to start at index 1, so we can specify it like that in Python. The interval and itself previous. We are going to use, are we actually going to keep, which one of the intervals are we going to keep? We are going to keep the one that has the minimum end value. So we're going to set previous end equal to the minimum of end and itself previous end. So that once we've updated this, we can use this new end value in the future iterations of the loop. But that's actually the entire algorithm.